Hello, thank you very much for attending the EMO Speakers Corner this afternoon and for your interest in additive manufacturing technology and our artificial intelligence and monitoring technology and the NIDEC machine tool corporation as such. I apologize, I can speak only English, no Italian, but I hope you can all follow the presentation. Let me just shortly introduce NIDEC Machine Tool Corporation, since we are a quite young company in a certain sense, but very experienced and old company in another sense. So before we were called Mitsubishi Heavy Industries Machine Tool, but since 2 months ago, August 2021, we became part of the NIDEC group and have a very good future ahead. And we have a lot of experience, especially in the field of metal cutting machine tools and tooling systems. And our main products are machine tools for gear machines and large scale, large part double column machines for the die and mold industry, as well as our laser and micro machining technology. And in 2014, our company decided to start developing our own additive manufacturing system. It's a direct energy depositioning system. And we quickly realized that the direct energy deposition system needs a very excellent monitoring technology in order to provide the quality that has been used in the metal cutting industry before. So, and then finally in 2019, we brought our first machine, the Lambda 200, to the market, and we continue to develop our features in the monitoring technology, as well as focus on especially large-scale parts for the aerospace and gas and oil industry. I would like to talk today about our technology updates, our advancements in the quality control system, introduce our local shield technology, as well as our large-scale part application. In order to do additive manufacturing, you have to have a different approach from traditional metal cutting industry. You have to do first new basic research to prepare the part and the process in order to build up. You have to look at the parameters such as topology, material. You have to simulate about the heat distortion during the process. And you have also finishing processes, just like heat treatment or parts quality control. And in order to bring everything together and to constantly monitoring the process of the build-up, an in-process control is essential to have the right quality together with the efficient use of material at a competitive cycle time. I want to show you shortly how the process basically works. So we have our nozzle at the end, which is providing the power and the laser energy to the part. And through a systems of mirror, a camera is constantly looking at the melting pool, observing the size, the heat of the melt pool. And this is constantly checked through the monitoring system and then feedback to the CNC control, and then adjusted either the feed rate of the deposition nozzle or the laser power will be adjusted in order to keep the process stable. So you can see if the feedback is off, too much energy is induced into the part and it will be destroyed or no good. So the purpose for this kind of process monitoring is, one is of course the quick the stabilization of the melt pool, as I just explained, but also to detect any abnormalities in the process and quickly counteract. So there's basically three systems that will help us. One is a stabilization of building features. For example, we can detect through artificial intelligence Is the melt pool, is the part going too low? Yes, the heat induced is too high, and the melting process is going too high or not enough, and it's building up and it comes dangerously close to the nozzle, maybe destroying something in the process. Another feature that can be used is to make the part build up very effective. Yeah, so we can have a very, very stable build-up and very thin walls, also using less material in the process. Another one feature is to detect abnormality during the monitoring, and here we teach the artificial intelligence systems what kind of effects we can observe during the build-up. This can be from the machine condition or the part quality itself. So here we can detect the sputter, if there's any abnormality, or we have any grains which are stuck to the surface which shouldn't be there. So the idea is to detect this as soon as possible in order to prevent it. And the worst thing is if some kind of foreign substances stick to the nozzle, and therefore we will also have an uneven laser distribution, and the quality will be insufficient. And finally, we can use this information to store and later analyze in order to continuously improve the process. Yeah? So we have an automatic system that shows us where the process is not functioning optimal, and with this we can improve the parameters and work to get a better result in the end. Next topic I would like to talk about is the local shield. It's a local atmosphere, which is especially important when we want to build up materials like titanium in order to prevent oxidization. So many additive manufacturing machines you will see require a special atmospheric chamber in order to keep the oxidization low. But this will, of course, limit the size of the part you can produce. And this is kind of our target, to be limitless in that sense, limited more by the machine and not by the process. And that's why we developed a special nozzle which distributes the power, the powder, the laser power, and the atmosphere through the nozzle. So it will create an atmosphere around the melt pool and give the material enough time to cool down to an acceptable level, reducing oxidization. And we compared similar systems on the market, and we actually achieve a very good distribution throughout the melting area, so that there's enough space covered to prevent the oxidation and to have a safe level of cooling down energy. Finally, I would like to talk about our large-scale part application. So we have already quite a wide range on the market of these systems, of these machines. So we started, as I said, with the Lambda 200. So 200 is standing for the dimensions, 200 millimeter in each direction. So this is more maybe an R&D application, but we also have the Lambda 500, which is a hybrid machine, and then the Lambda 2000, which also offers a variety of features such as hybrid machining or parts up to 2.5 meter in length. The laser power we can provide is 1 to 6 kilowatts, and materials we work with and we have experience with is titanium alloy, Inconel, stainless steel, and other alloys like cobalt chromium. This year we delivered actually our first large-scale machine into the aerospace industry, use it for mass production. So it shows this system is also ready to be industrialized. Finally, I would like to just show you a sample which our engineers created in our headquarters in Japan. It's a rocket sample. It's about 1.5 meter high, and the diameter of the large part is 140 millimeter, and we built it with our Lambda 2000 prototype. And I just want to show you here a short video. This is a time lapse on the left side, building up this rocket with titanium material. And then on the right side, you can see how the process is working in real time. Okay, that's all from my side about our technology. I hope you learned something new, you found it interesting, what we have to offer. So if you would like to learn more, maybe you have a few questions right after this presentation, but you're also welcome to visit us in hall number 2 at booth E48, NIDEC Machine Tool Corporation. Thank you very much.